want to do, see, we have to have this model. This model goes to the casting department, you know, and they use this to make their molds and their cores, things like that. Use it to verify the geometry of the finished casting. What we need to do is keep this. We don't want to upset this at all. This is somebody else's whole bailiwick. We need to be completely removed from them. What we want to do is take this and create an associative link back to this model so that if this model ever changes, our model will update. And we need to model the machined casting. Okay? Alright, so what we're going to do is we're going to wind up, if we were going to machine this casting, we'd have an assembly in here. I mean, what would it take to have a machined casting? You'd have to start with a casting, right? So what this is, in a way, is an assembly that includes one line item in the bill of materials, and that's the casting. Okay? So we'll level up. Here's our casting PRT. We're going to create an assembly that has this as a child in that assembly. So what we need is to go up a level. So we could do this by going out and saying File, New, Assembly, and we could, you could do this, go out and make a new assembly. And actually, this model is done in millimeters, but we're going to create well, let's see. I don't remember how this worked last time. All right, so we could go out and do that, but there's a shortcut. We learned a shortcut to doing that. If we're at this level and we realize, wait a minute, this is actually a component in a higher level assembly. What do we do?
Create parent?
Yeah, new parent. Create new parent. And let's see. We're going to create it in inches, even though that first model is in mm. And we're going to make sure to keep these on the same directory. I put mine on the desktop, so this should be on the desktop as well. And you need to give it the name. What is this name? Can you tell you anyone out here? Yeah, my whole world stuff. Oh, this is number 13. So just make sure it has HW13. This model, this assembly, is going to actually be the model for the machined part. Okay, so this is homework 13, your UUID, which is not your U number, by the way. That's your email.
You get an error when you try to do it in inches.
Yeah, I got it.
Yeah, it's a sort of soft error, though, isn't it?
Yes, sir.
All right, so he says, hey, you won't be able to work in context if you do that. What that means is we won't be able to come in here and double click on this and make it the work part. Okay. So yeah, it's bad form. It's a bad idea. But I forgot that I made the brake rotor in millimeters, and then I did the assignment in inches. Oh, let's see. So what we're looking at right here, we're in the assembly now. Okay? We're in assembly, and this is your homework 13 UUID. This is an assembly now, and it references this casting. Now, if I were to try to double click on this and add a sketch and start machining on it, that's not what I want to do. Okay? What I need is sort of an exact replica of this. Do y'all know how to do that? You wouldn't necessarily know.
Control copy, control.
Do a insert associative copy. Yeah, we've used this thing before, but we used it to do a sort of a funny thing. We're going to use the wave geometry linker. Insert associative copy, wave geometry linker. So really, I know y'all think I'm going fast. We did create a new parent.
He's becoming aware.
I can speak to that if you'd like. Okay? What I don't want to prepare you for in industry is for somebody to be sitting behind you saying, all right, click that icon, move left, enter 6.0, hit enter. That's not the world I'm training you for. Okay, that's not what you're being educated to do. All right, so anyway, The next new command, it's not even new, you've used it before, we're using it in a different way. Insert associative copy, wave geometry linker, okay? And of course you can search for that. Wave geometry linker, and what we want is a body. You see, last time we did a mirror body, which was really slick, okay? Kind of a nice way to get a duplicate, but the reverse of that. In this case, we just want a plain old body. All right, it says select bodies, there, selected, and just say okay. Now see, that wasn't that hard. All right. Now, what are we looking at? It doesn't look like it did anything. It doesn't look any different than it did 10 minutes ago. 3 minutes ago. All right. What we're looking at is two things that are occupying the exact same space. We're looking at, number one, at this in the assembly as the casting. We're seeing the casting. Notice when I click on it, it looks kind of like it's hatched or something. Kind of weird looking. Okay.
Wouldn't you look weird if you had another you occupying the same space?
Yeah, that would be weird. Yeah. Y'all stay off the mushrooms. All right. Over here, you look down here. This is a linked body. It too is occupying the same space as the component in the assembly. All right. Well, at this stage, we're basically done with the assembly component. So we can come in here and we can turn that off. So the assembly, the casting is now gone, and we are left with this thing. Okay, this is it's a duplicate, but it's an associative duplicate of the casting. So we could go in and edit this and modify it. We can machine this surface and the bottom surface. We can drill holes in it. But if this geometry changed, like if this the diameter got bigger or smaller, or a fillet changed, it would be updated at this level. Okay, so it would trickle through.
So the what is it? The casting original wouldn't care. It
No,
just keeps
casting
on
original
going.
doesn't know. In fact, we could take that one casting and we could make a whole bunch of different product lines out of it. We could machine it into different brake rotors. You know, we could do different hole patterns and stuff in there. All different things. So we could have 5 or 6 or 20 different machined rotors that are all based on the same casting. And that's very regularly done, that kind of thing. All right, so now what we want, there's something missing out of here that I would like to have if I was going to be modeling, because we did this as a create parent. It kind of thought we were going to just be doing assemblies up here at this level, so it didn't put in a pretty useful little bit that we're used to having. You know what that little piece is? Yeah, that little datum CSYS. It's just handy to have. I'm really used to getting those now. So I'll just say, where are we? Home maybe? Datum CSYS. And it should come in right there. At that point, we'll say, okay. Ooh, there's one thing I kind of forgot to do. Back when we put this casting in originally, I think it's good practice to fix that. So put a fixed constraint on it. For assembly constraints, we'll grab that and just put a fixed on it. Whoops. Man, everybody does that.
Oh.
Now, so you should have, it should say in your constraints, you should have this fix on here.
Where do you click for it?
And then I'm just going to turn that off. So that'll keep this thing fixed in space.
Won't let me select the.
Yeah.
Which part?
It won't let me select.
The constraint.
Alright, so I'm going to delete this off of here. Alright, so you're under assembly constraint. Do you have is the casting enabled? I mean, is it visible?
No.
Need to be?
Does it need to be?
Yes.
Okay.
Oh.
Yeah, assembly constraints, and then apply that fixed constraint So apply and then cancel, and you should be in here like that. Then just suppress that casting, and you'll be left with a complete body. And it doesn't really make sense.
I already turned it on.
So now you just click on fix and then click on the body.
Okay, cool. So
I'm gonna turn casting back off.
Yeah.
So we just make the parent stay still. We can move the kid all we want. I think.
Oh, it's
All right, so we've got three little dimensions that we need to put on here. Okay. There are a couple of ways you can do this. I'm going to show you one that I'm going to ask you not to do it. There's really nothing wrong with doing it this way, but just watch for a second. You could come in here with a datum plane, and we will do this. You'll put a datum plane that's the a bisecting datum plane in between those two surfaces there to get on the mid plane. So if you have that there, what we could do is we could put a datum plane that was offset from this one, 0.35, from that center plane right there. And there is a thing called a trim body that would let you come in here, and this is the target, and the tool will trim with this plane, and you see you could trim that layer off across that plane with the trim body. So that is one way to machine that side of the casting.
How far did you say to offset the second down?
Well, see, our print says 0.35. I know this PDF just did not print well at all.
I see it. Okay.
But don't do it that way. That's an okay way. But there's one way that does it that lets us capture all the information in one place. Based on what you know, how could you go into this model at this point and trim off those surfaces? Machine a layer off of the top, machine a layer off of the sides of the rotor. Any suggestions for removing that material?
Do subtract?
Could do some quick.
Yeah, so you could subtract. How would you? Where would the geometry come from that you would subtract away? So you want to make some solid geometry, right? Yeah. So you do a sketch. As you know, that's a real good way to start thinking. So, how would you orient said sketch or sketches? Where would you put it, and what would you do to get it to subtract away? All right, put it on this datum plane? Yeah, you could do that. And then what would your sketch look like?
Something big to subtract away.
Yeah, you could sketch a circle on here, and you could extrude that circle to cut away here, to cut away there, and to cut away there. So you'd have to have like a donut-shaped circle sketch to trim this, because you'd want to be able to trim this without trimming anything in here. So that means you'd have to have an inner boundary and an outer boundary, and you could use that one sketch that was a donut shape to sketch and move that away. The only problem with that is, and it's not really a big problem, but it's that you'd have to think about what would be your start distance and your end distance, and then your start distance in this direction. And the print actually says, if we look at how the print's dimensioned, it starts at this plane, it goes down, but then from this level, it goes back up. And then again from that level, it goes back up. So there is a way that you could get all of that information actually entered into the sketch and have that all spelled out in a single sketch, and then do one single operation that would allow you to remove material from all three surfaces with one sketch and with one one operation. What would that sketch look like? Where would it be?
Would it be on the XY plane and then you could revolve it?
Yes. It'd be on the XY or the ZY plane, and you would revolve it. Okay, so here's, if you can't figure out what that would look like, let's just do a sketch and we'll put it there on XY. Now it's kind of hard to see what's going on here, and it's going to be important that we don't gouge in here on this inside area where this is, so we need to be able to see that information a little bit. So I'm going to go out to the view and put a section view on there. Now I got lucky that time, and he put the section view right down through the XY plane. Oh, you probably don't have this turned on. You can see the actual sketch. I mean the section lines. If you come out to your assembly navigator, I'm not sure why it's in the assembly navigator, but there it is. And you can select sections, and you can turn those on so you can see it really nice and clearly.
That's nice.
All right. And now, let's see, now I'm going to put in a rectangle here, and a rectangle here, and a rectangle up here.
How do we get the like that?
Now, that's an awful lot of auto dimensions.
Sections probably.
For what we really only need 3 dimensions to control, right? We've got the 0.35 that's going to go here. We've got the 0.7 that's going to go there. Oh, look, I nailed it. 0.7 is going to go there. And then we've got, what is it, 1.25 or something up here to this surface from the box. All right? But we've got to get rid of the auto dimensions because the thing is, if you don't get rid of them, if you don't tie them down, then they will move. Okay, so what I'm going to do is I'm going to start with the dimensions that I really need. I need to have the distance from this center plane. Now you'll notice it looks like I can't select that datum plane. And my whole idea was to base this on that datum plane. So this is the kind of stuff you'll run into on a test. Any other time you'd be able to select that datum plane. Here's why. It's because you're looking at it in section. If you tip this up a little bit and select the datum plane, he doesn't have any trouble selecting. So from there to there, that's our 0.35. And this, since it's already an auto dimension there, I can edit that. Now since it already says 0.7, I need to change that text somehow so he knows that it's actually changed. So I'll just make it 0.70. That's good. And the other number is 1 1/4. Alright, now you might make the argument and say, well, that's really the only thing that matters, and so who cares if they're auto dimensions? I know that Hewitt used to get all in a panic about them, but this is what matters. These other things don't matter so much. Well, let me show you what will happen. Okay, here's what will happen. I'll finish this, and we'll come back and do that later. We'll finish finish constraining. Here's where we're going to go from here. We're going to make this revolve. We're going to revolve it around the actual, let me see if I can get that y-axis. There we go. Revolve it around the same axis as the axle of the car. We're going to subtract, say okay. And there, that's, now those sketches have done their jobs. All right, and it looks like everything worked out just fine. And yeah, this time it did. Okay? But here's what's going to happen. Somebody else will be coming in here. You might come later, you might take a look at this sketch and not realize, oh, look at this stuff. See how that can just move around? Well, thankfully it didn't do any damage. We'll hit enter or finish sketch. There, you see that? See that little blip right there? Is that supposed to be there? No. So let me give you a story about what's gonna happen if that little air winds up creeping in, okay? Nice little subtle air, it's almost right, you know? Here's what happens, that somebody uses
Real
this to
subtle.
program the CNC that goes in and does this machining, and they wind up making a whole bunch of these and ship them off to AutoZone, and they get installed on some customer's car, and it tears up the brakes somehow because there's extra metal in here that's not supposed to be there. And there's going to be a recall, and there's going to be an investigation. And where is that investigation going to end? With you, okay? It's going to end with you, and they will solve that problem, okay? So just out of an abundance of caution, and to show good form, I'm going to recommend that you always get rid of all of your auto dimensions, whether you think they matter or not. All right? So I'm going to start, just to get rid of them all. This is not, you know, I want to try to use as much geometry as I can. That would be nice. Let's see, that line and that line. And I'll just make those equal length, all three of these. Equal length, that'll take care of that. And they're going to be 0.25, I guess. And then I'll just align these vertically. Oh, come on, give me the vertical line on those. And now I need to fix it left and right somehow. I'm just gonna put this, make it lie on that, right in the center. I need to make it long enough. And there is, you know, there is some leeway with this. You can make this whatever you need it to be. I might like these two to line up, just for fun. And then now I can position this like that. I'm gonna make this hold on to it. So now it's not gonna move it's not gonna move left or right. That's one of the most important things I need to figure out, make sure that stays. This needs to be a little bit bigger. You stretch it out and see how much bigger. 2 1/4 looks good. And I can just make this lie on that same y-axis too. No harm in that. So I don't have a whole bunch of extra dimensions. But see, this dimension, yeah, it actually has some meaning. That actually needs to be, at least this 1.93 is holding this where it's not going to get shifted out of position. And these are going to be long enough that they don't get cut. Finish that up, and now my machining looks a little better. Alright, so now our assembly is actually, it's its own component. Alright, but in order to make this component, you have to bring in a casting. So a casting is required, so there would probably be on here, even on the bill of materials, bring in a casting. You need the casting for that. Alright, now there's another part to this. Does anybody have any questions on this part? At least, you know, if you haven't gotten it all done, is there anything you don't understand about this? Yeah.
What level of precision are we looking for on what's getting like milled off?
So the parts that get machined, it's just going to be this flat surface. So actually the distance of that flat surface to this center plane is what's critical. Then the other dimension is to just make sure that we're trimming off enough, but not too much. And so we have a little you know, this little relief in here is actually there so that we can so that the machinist can go in there and machine that whole surface flat. And then have a little extra for the tool to get parked in while he comes back and does the rest. So, so that's flexible as long as it, you know, that's really dependent on the casting itself, how much relief is in there for that machining operation. But what really matters, what's critical in this case is distance down, distance up. That makes the width of this critical, and then the distance from this outer face to the top face. Those are what's critical. So those need to be dead on. In fact, everybody's model, the geometry of the models will all wind up being identical. They'll all be identical to each other. There's no, in terms of the solid. Now in terms of your sketches may have all kinds of variation in them. But what gets produced will be identical. Yeah.
I was gonna say, can you redo the bottom square that you did? Just the dimensioning of it.
Yeah, so the dimension that's critical is this. The other dimensions are there to keep it from moving around.
Okay.
So that it'll hold it in space left and right.
How did you get your center log?
I put this datum plane in here. And when I dimensioned the first, this 0.35 is actually the thing that keeps everything nicely centered. See, if I take that out, all this stuff can move around.
Yeah.
All right, so it's the rapid dimension. Now, if you look at it dead on, and you try to dimension from that center plane, he's not gonna let you have it. He thinks you can't see it. But if you tip it and say, yeah, that is there, and it's because it's in the section view, there's kind of a law that NX likes to use, and it's like, if you can't see it on the screen, then NX pretends that he can't see it. And since this has actually been cut, what you're clicking here is not an edge.
datum plane.
You're seeing,
My datum
not an
plane's
edge,
also
you're seeing a
Yeah,
slice
that's from the
plane,
bottom.
not the plane itself.
You should add a data.
That datum plane was 0.35, right? Off the bottom face?
Yeah.
Huh.
Not off the bottom face, off the center plane.
Off the center plane?
The
Yeah.
datum plane
Yeah,
is
this-
bisecting the inside.
This plane
Oh,
right here
okay.
that goes down the middle,
Mm-hmm.
yeah, that's the center plane, and then
Oh.
0.35 off of that.
I see you. Oh, bisector. I see you. Nice. Nice.
Would you click right here?
Datum plane bisector, yeah, and then hit the
All
top
right,
face.
there's
of the
one
bottom.
other part to
Hit the top
this.
what?
The top face.
Right.
Top
So if you
inside
haven't
face and
quite
bottom
got
inside
the machine
face.
part down,
So like,
Right here?
yeah.
well, you probably just follow along from here. I'm gonna turn this section view off, and then I'm gonna uncheck my sections. A lot you can do with those actions, pretty neat. All right, so now we need to put on these holes, okay, the little cooling holes here. And the only real information that we have is that they're 0.18 inches in diameter. They do not intersect the fins, and there's going to be 4 of these holes in each of the 10 sets of holes. Okay, so that means that we have a little bit of freedom as long as we can kind of justify what we're doing. First of all, I want to put my sketch to locate my planes on this bottom surface. But I need to be able to see the fins to be able to do that. And so what I'm going to do is, let's see, I'm going to do my clip section, or my edit section in this case, because I need to orient this differently. So I'm going to click my Z axis, and then click this face. That's going to orient in that direction. Let's see, I'm going to double click it to send it the other way. So now it's actually cutting through this direction. But if I say OK, and I turn my section lines on, I can see real nicely where those section lines lie in this view. And I can either turn that on or off, either way. All right, so I'm going to go in and make a sketch. Now I know you could go into the hold command and do a sketch there, but I'm going to do this a little differently. I want to do my sketch first, position my points first of all, and then later add my hole to pre-existing points. All right, now what I'd like to do is just come in here and draw a line from the end point to the end point of that part. Now that's not gonna work, let's see, crap, because I've actually turned off what I wanted to see. Yeah. All right, Fisher cut date. What I've got to do at this point, get rid of that sketch. I don't want to have an extra sketch. I'm gonna flip this whole thing over and do it from the other direction. I'm gonna double click my Z axis and it just reverses the whole thing. Because see, what I'm after I could have done it that way. What I'm after is this intersection. Okay, so do this again. Home sketch. We're gonna put a sketch on this face. Now I'm trying to get to this geometry back in here. I'm trying to get to that end point, but it's not finding it. Okay. Here's what you can do when you know there's an edge back there, but you can't get to it from within the sketch. There's this little jewel down here. I've shown you once, but it was a real fast show, so it's conceivable you didn't get it. Project curve. Okay? So if we do project curve, we can come inside where that edge is. And click, we can get that edge and that edge, and say okay. And you see what he did? He took those edges and projected them to the plane of my sketch. You'll also see they're kind of a light blue color like that. These are what are called recipe curves. They are in my sketch, and you see it says the sketch is fully constrained, but these two curves are constrained at a whole nother level. They're constrained because the geometry that they're projecting from is fixed. And so they're in my sketch now, and I can use them in my sketch. So here's what I'm going to do with them. I'm going to use them to set up sort of a little scaffolding that I can put my hole locations on. So I want this endpoint and that endpoint connected. And you'll see what I'm doing here in a second. That endpoint and that endpoint. And then I want the two midpoints connected. I want to be careful that I don't have this point on a curve turned on. I want to make sure I'm only getting midpoint. There, so that, from that midpoint to that midpoint. So what I want is my hole locations to be in between these two arcs. So I'm going to put my own arc in between those two. I'm going to start at this end, go to the other end, and then you might expect me to want to snap to the midpoint of that middle line, but it's a little bit more complicated than that. You see, if I put the midpoint of this circle on the midpoint of that line, if I try to constrain that to lie on that midpoint, coincident, it over constrains. Alright? Because they can't be at the same point, and this be an arc, and all this other stuff happening. What really has to happen is the midpoint of this line has to lie, the curve has to pass through the midpoint of this line, which means I need to place the midpoint of this line somewhere on this curve. And there is a constraint for that. Let me get rid of this offending constraint right here. Delete. So midpoint of the curve, midpoint, and then the curve itself. And you see there's this constraint, point on a curve. Point on a curve. So if I do that, now my sketch, my arc is in between the two arcs at the beginning, at the end, and in the middle.
Did you just copy that middle arc? Or the green arc in this one?
Actually, it's different from either of these other two arcs. Because you see how this little feature gets tapered a little bit. that means that the inside is one arc, the outside is another arc. And here we got an inside arc, here we got an outside arc. And that's the reason that they don't lie, that this won't constrain midpoint to midpoint. So it's a different arc from either of those two.
I'm sorry to back you up. How do you do the curves again?
The project curve?
Project curve?
It is this little animal right here. Alright, so what he expects, what he'll project, he can't project a face. Okay, because that doesn't really make any sense. You might think, well, he should be able to see this face and project it, but he doesn't do that. He'll project an edge. So you can say project sketch or project curve, and then what you want to pick is this little edge right inside here. That's not showing up too well. But that edge where the two intersect each other, where the fin intersects that part of the road. I'll do it again just for fun. That goes in, and say apply. You see it's created that projection of where that curve would intersect. It's what that curve looks like from this sketch's point of view.
Yeah, it's shooting mine off the other door. I mean, it's putting it in, it's just throwing it all the way.
If it's on another, if it's in the other direct, I mean, that's where it's going to put it onto the plane that you're sketching on.
Ah.
So that's why it's off the surface there, but that's the plane that I'm sketching on. If I look at it from the side, that's where my sketch is at. But I'm going to delete that out. Alright, I'm going to actually finish this sketch. It says it's fully constrained, so that's good. I'm not even going to make anything reference geometry. There's no need for that. And you might think, well, why didn't you go ahead and just put the points in there? Just because I want to show you this one neat little thing. We're going to have a group of holes lying on here. You go to curve and then go to point. There's a thing called a point set. I just wanted to show you one way to use this thing. Pretty nice. So under the curve tab, point set, and just search for point set. And we want curve points, and we're going to select that curve. Well, that kind of takes the fun out of it. It's already got my last defaults in there. Yours might say 2 and 5 and 95 or something like that. We want 4 points. And then it says the start percentage. You see, it could go all the way down to 0 and 100%. And that would mean this point set would start at the very beginning of this curve. But we want it to actually, we want to bring it in a little bit, so I'm going to bring it in 10%. And we want to end not at 100%, but at 90%.
How do you know that?
See, that's the thing. You don't have an actual print on this that's telling you where to put the holes. And so in this case, everybody's will be a little bit different, perhaps. All right. In fact, unless everybody chose 10% and 90%. But if I didn't spell this out and say the holes need to be here, we're going to say that we've got the leeway as long as we've got a nice, a nice hole diameter off of this hole where it begins. We'll be in good shape. But yeah, that we're not giving. So we're this would be the person doing the design now instead of the person just putting in somebody else's parameters. This should be somewhat familiar to you from working on your Sterling, where you're coming up with the parameters. All right, when that's done, you're ready to put the holes in. What must I have that? All right, I can turn off that section view, turn those sections on. Now you know how to do this. I'm going to put in a hole. Well, a hole always disappears. Insert design feature manually a hole. And instead of just picking point by point, I can actually stop and I can pick the whole point set at one time. 0.18, and they go all the way through the body. And when you get that, you're done. Oh, no, you're not. You've got one small step. You need to make 10 of these. That's the fun part. Pattern feature, circular. The part to select feature is going to be those holes. The vector. Y'all know where the vector is going to be for this circular array, for this pattern feature? The vector. Yeah, it'd be y, and you know, if we actually get this y-axis from our datum CSYS, we won't have to even select a point. It's inferred. Alright, so we use count and pitch, count and span, pitch and span, and list. Are y'all understanding the difference of these? What was the information we were given? We want 10 of them equally spaced all the way around. Were we given the count and the pitch, or the count and the span, or the pitch and the span? We were given count and span. So why don't we just put in count and span? Because we know what the count and span are. There's 10 of them at around 360 degrees. There, now you're done. And of course, you'd spend an extra couple of minutes, and you put all your sketches on the sketch layer, you put your datums on the datum layer, and you probably make them invisible. Any of this you want to see again at any level?
Yeah, so I got the 3 lines going back